Hi and welcome to this video on indirect proportion. It's a GCSE higher topic and is more than likely going to appear on the calculator paper. Okay, what we're going to look at in this video is the idea of indirect proportion. I'm going to give you some examples, a test yourself question, and then at the end there'll be some revision card notes for you to make. Okay, let's have a look, see what we're talking about in terms of inverse proportionality. If two quantities are related in such a way that one is increasing by a factor of k and the other is decreasing by a factor of 1 over k, we say that they're inversely proportional. If you're not sure what I'm talking about in terms of the k, check out the other video, the direct proportional, where I go into that in a little bit more detail. Let's just have a quick look here. In this case where I'm looking at a van, Auto's van hire is £120 per week. But if more than one person shares that cost out, it'll get cheaper. So if two people were to share the cost, it becomes half. And if three people share the cost, it becomes a third of the cost. We'd end up with a graph looking something like this. And we can say that the cost C is inversely proportional to the number of people that want to hire it. So inversely proportional to the number of people. So C is proportional to 1 over n, or C equals k over n. Okay, we're going to do some more work on this in a second. Let's just have a little look at the inversely proportional. Notice that the proportional sign's the same. We're still converting from a fish symbol into a k, so we can work out our constant of proportionality. Okay, let's do this example then. Boyle's law states that at a constant temperature the volume V of a gas is inversely proportional to its pressure. When the pressure is 600 newtons per metre squared, the volume is 4 metres cubed. Find the volume when the pressure is 400 newtons metres squared and the pressure when the volume of the gas is 5 metres cubed. Okay, before we even worry about part A and part B, let's just jot down what we need to do with the first part of the question. It says that the constant temperature, the volume V, so V is inversely proportional, so 1 over its pressure. So it's not pressure squared or anything like that. Even though pressure is measured in meters squared, we're still interested in V is proportional to 1 over P. That means that V equals K over P. And there should be some information in the question to help us work out what K is. It says when the pressure is 600, the volume is 4. Okay, so let's do that then. So V equals K over P. Oh, I've written that already. I don't need to do that. What I do need to do is to say that when the volume is, the pressure is 600, the volume. So V, so 4 equals K over 600. So in this case, K is going to be 2,400. Okay, I've got myself a new formula to use. Here we go. It now says that V equals 2,400 over P. Okay, and I'm going to use this formula to answer the rest of the questions. Okay, let's do that then. The volume when the pressure is 400. Okay, so now I'm working out part A, and part A, I'm trying to work out V equals 2,400 divided by whatever the pressure is, 400. Okay, this case it must be that V is equal to 6. Done. Part B, we'll be working the other way around. This time we're told that the volume is 5. We know we've got 2,400 divided by P. I want to work out what P is. P is going to be 2,400 divided by 5, which is going to give me an answer of 4 280. Okay. Very similar sorts of questions to the ones that were directly proportional. This time it's inversely, it just means 1 over. Okay, if you're happy to have a go at this example by yourself, please do so. If you're not happy to pause the video at this point and you just want to watch me do it again, that's fine. Let's have a look. The time t taken for Germany to the moon is inversely proportional to the average speed of the spaceship. Okay, so t proportional to 1 over s. T equals k over s. Notice I haven't done anything else yet. I've not even finished reading the question in terms of the numbers involved. I've turned my first bit of my sentence into a mathematical formula here. Let me keep going. If the trip takes 20 days, so t is 20 over k over 12,000. Okay, let's see if we can work out the other stuff. Well, first of all, I need to know what k is. Well, k is going to be equal to 20 times 12,000, which is going to give me 240,000. So my formula is t equals 240,000 over s. This is the formula I'm going to use to work out the rest of the questions. Okay, let's see if we can work them out then. The time taken at an average speed of 16,000. So part A, t equals 240,000 divided by 16,000. Okay, so again I'm using my calculator here just to work this bit out. I could do it in my head, but I can't be bothered. It equals 15, and its average speed, days, so 15 days. I almost wrote seconds there, it's a ridiculous answer. So 15 days. Okay, and the second part is going to be the reverse of it. This time we're told that time is 24 days, so 24 equals 2,400 divided by s. That means that s is equal to 2,400 divided by 24. So s must be 1,000. Okay, so we're looking at 1,000 miles per hour. Okay, here's a question for you to have a go at by yourself. Pause the video and then I'll go through it. Okay, so this one, it says that the force F between two magnets is inversely proportional to the square of their distance. Okay, so proportional to 1 over d squared. Let's put the numbers in. So when the magnets are 2 centimeters apart, the force of attraction is 24. So let's keep going. F equals k over d squared. The force is 24 units, so 24 equals k over d squared, so that's going to be 4. Multiply these up, so k equals 24 times 4 is 96. So my new formula is F equals 96, that was k before, here it is, 96 over d squared. This is the formula I'm now going to use for the rest of my equations. Rest of my questions. Part A, the force of attraction between two magnets that are half a centimetre apart. Okay, so let's do this then. So F equals 96 divided by a half squared. Okay, so F equals 96 divided by a quarter. It's going to get bigger. Remember, when we're dividing by a fraction, my answer is going to get bigger. 96 divided by a quarter is going to give me 384 units. Let's look at part B. The distance between two magnets and the force of attraction is 6 units. So let's see what we have to do here then. The distance, okay, so F is 6. So 6 equals 96 divided by d squared. I'm going to swap over my d squared and my 6, so I've now got d squared equals 96 over 6. 96 divided by 6 is going to give me 16. D squared equals 16. That means that D is going to give me 4. Done. Okay, hopefully you got the right answers there. Notes on this, and for your revision cards, these are the key parts to remember. So y is proportional to 1 over x. That means that y equals k over x. This could be squared, of course, like we saw in the last question. Substitute your values in to find k. Once you've got k, you can work out the rest of the question. Okay, good luck with this topic. Hopefully this has made it a little bit clearer for you, and good luck with your exams.